Hi everybody, my name is McKinley Burns and today we're going to be talking about Fluorouracil. I'm not sure if I'm pronouncing that correctly, but that's how I'm going to pronounce it during this video. So what is Fluorouracil? It is also known as 5-FU, which is what I'm going to be referring to it as in this PowerPoint. And it's the most common drug used to treat cancer. And some common cancers that it is used to treat are breast cancer, stomach cancer, colon cancers, and there was a long list of other cancers. Those were just the ones that I wanted to use. This drug is important because it's a type of drug known as anti-metabolites, and it stops the cells making and repairing the DNA, which in turn causes the cancer to stop growing and multiplying. How is fluorouracil metabolized by cells? So the majority of 5-FU is metabolized to fluorodeoxyribonucleic monophosphate in the liver or intestinal mucosa by dihydrouracil dehydrogenase. 5-FU also is mostly active during the S phase of the cell cycle, inhibiting DNA synthesis by restricting the availability of thymidylate. So 5-FU inhibits thymidylate synthetase through its metabolite fluorodeoxyuridine. And how does fluorouracil inhibit RNA synthesis? So because 5-FU is an inhibitor of the enzyme thymidylate synthetase, it converts DUMP to DTMP. Because TS is inhibited, it leads to a depletion of DTTP pools, accompanied by an accumulation of DUTP, resulting in the misincorporation of deoxyuridine into newly synthesized DNA. So this is important when we start talking about the mechanism. So what is the mechanism for how the inhibition works? So the main mechanism of 5-FU activation is conversion to fluorouridine monophosphate, either directly or indirectly. So directly by orotate with phosphoibosyl pyrophosphate as the cofactor, or indirectly via fluorouridine through the sequential action of uridine, phosphorylase, and uridine. So the mechanism for fluorouracil looks like this, and I wanted to incorporate a picture because I was confused, and so this shows you the indirect pathway and the direct pathway of how fluorouracil works. And so it starts at the 5-FU and then goes indirectly and then directly. So how does this tie into the medical community? So the response rate of this drug is 40 to 50%. So that means that the way that people respond to this drug is that percentage. It also has made a huge impact on those that do get to take this drug, because not everybody has the same cancer, not everybody can take the same drugs. Some people might be allergic to this drug or, what have you. So the people that do get to take this drug, it's significant because there's a 40 to 50% chance that the response rate is going to be even better. And I also would like to note that this does give us a perspective of the kinds of drugs that people have to take to help fight their cancer or to help treat their cancer. And I thought that was important to note because if you don't have cancer, then you're not going to realize the effects that these kinds of things have on people or what have you. So to me, it was important to learn because I know a lot of people in my life that has had these types of cancers, and to know that they could take this drug and it would help them a lot more than, you know, whatever other kind of drug there is. So I just thought that was very cool to see and very interesting to learn about. And then those were my sources as well.